Thank you so much, Leslie, and welcome everybody on behalf of Professor Jules White and I. We're really looking forward to talking with you folks today. I'm going to start off the talk, then I'll transition over to Jules, and I'm going to start by talking about how we're going to assure the future of software engineering and AI engineering. And I'm doing this talk with sort of two hats on. I'm a professor at Vanderbilt University, but I've also worked for almost 20 years with the Software Engineering Institute at Carnegie Mellon University, and you'll see why that's relevant on the very next slide. So about 3 years ago, we being myself and my colleagues at CMU's Software Engineering Institute, started doing a study on architecting the future of software engineering. And this was in conjunction with DARPA and the National Science Foundation. And the idea was to try to figure out how we could define a roadmap and a strategy and vision for the next generation of software-reliant systems. And this was published November 2021. Remember that date, that's going to be relevant in just a moment. The study focused on a whole bunch of topics: AI-augmented software development, assuring continuously evolving software systems, software construction through compositional correctness, engineering AI-enabled software systems, engineering societal scale systems, and engineering quantum computing software systems. I'll talk a bit about a couple of those topics in a minute, but I want to focus on one important thing here. The goal of the study was to look 10 to 15 years down the road. So people said, don't just think about the next couple of years, really start trying to do some things that are going to be far out. So at the time, again, 2 and 3 years ago, we thought a far out vision would be one where the current notion of software development would be replaced by one where the software pipeline consists of humans and AI as trustworthy collaborators that rapidly evolve systems based on programmer intent. And I remember thinking at the time, that's a great long-term vision. I'll probably be retired in 10 to 15 years. I don't have to deal with the consequences of anything. This is great. Well, then, as you all know, literally a year after we released the study, ChatGPT escaped from the lab. And unless you've been frozen in carbonite the last couple of months, you know that ChatGPT and large language models are part of this generative AI concept where models or systems are synthesized and synthesizing new and oftentimes original content. So that's all really exciting for technologists like many of us. However, a lot of people think the world is coming to an end, and you don't have to look very far to search, is AI the end of the world on Google or Bing or whatnot, and you'll find all these studies and articles talking about how this is the end of humanity as we know it. And to quote Ron Burgundy from the Anchorman movies, boy, that escalated quickly. So I'm not actually here to opine on whether AI is in fact the end of the world. But I will note that if it is the end of the world, it'll certainly make it easier for us to think about the future of software engineering and AI engineering, since we don't have to think very far down the road because it's the end of humanity. Now, let's assume, for sake of discussion, that's not going to happen. And instead, what we need to do is think about, where is this going? How will software engineering, how will AI engineering work together? And what can we do as researchers and product managers and project managers in this space to help make things turn out well for humanity and not turn us into some dysfunctional hellscape? So what I'm going to do is I'm going to take a look at a couple of the topic areas in the study that we did, published 18 months ago or so, and focus on AI-augmented software development and engineering of AI-enabled software systems. These are the things I'm going to focus on. There's also some other material we've produced in the last couple of weeks, thinking through some of the other areas and how generative AI may affect some of the findings we had. And you're welcome to read about that in our blog series, but I'm going to focus on the two ones that are most relevant to AI. So let's start by talking about impact on AI-augmented software development of generative AI models. As many of you probably grew up in the 70s like I did, you watched the Philadelphia 76ers and you remember Dr. J, and his signature move was the dunk. And they asked him, Dr. J, why do you like dunks so much? And he said, well, it's a high percentage shot. So I'm going to start out with a high percentage prediction, which is kind of obvious, that generative AI is and will have a very transformational impact on the practice of how we build software and we engineer software. Now, this is sort of obvious, and if it doesn't take too much time exploring all the new tools that have appeared in the last 6 months or so, things like Code Whisperer and Copilot and Tab9 and so on. And these tools are really intended to help improve the efficiency and the quality of software engineers in order to reduce their cognitive load. And it's beyond the scope of this talk for me to go into details of why I believe that's so relevant and happening. I have another video where I talk about this based on the work I've done at Vanderbilt, introducing ChatGPT and other tools into the courses I've taught over the past semester. But that's a topic for another time. What's also worth noting is not everybody is equally bullish about how this generative AI is going to make a difference. You could read an article by Bertrand Meyer, who's a famous software engineering researcher, and the person who developed the Eiffel programming language, entitled AI Does Not Help Programmers. Now, I understand his points. I respect his points. I'm thrilled that we have other people with different views on this. I don't quite agree with him for reasons I'll talk about. I think AI is going to have an amazing impact on programmers. So even though I'm very bullish on this, there's a bunch of challenges we have to think through. One of them, of course, is how to train all these large language models on better vetted and more robust code bases. If you take much time poking around the web and looking at open source repositories, there's a lot of good stuff out there, but there's also a lot of really bad code. And so if we train our models on bad code, it should be no surprise that we get hallucinations and bad outputs with security holes and vulnerabilities and just incorrect results that don't compile and don't run properly a non-trivial amount of the time. Stepping a little bit further upstream from programming, there's also a bunch of other aspects in the software development lifecycle where I'm very confident that these tools, generative AI and otherwise automation-based tools, are going to make a big difference. We're starting to see the use of things like LangChain, which is bringing together other tools beyond just the large language models to solve problems more holistically. And I think that's also exactly what will happen or is happening in the context of the more upstream aspects of software development, things like requirements analysis, specification, design documents, testing, and so on. In fact, if you think about the data that's generated throughout the software development lifecycle, there's a lot of non-code artifacts that can be analyzed much better at scale by AI tools in a way that's better, faster, and cheaper than expecting humans to do this. And I'm thinking here about plowing through large requirement specifications, looking for consistency, looking at various types of design documents and architecture diagrams, looking at test plans, and so on. There are people who can do this, but it's often very tedious. And I don't know about you, but I really don't want to spend all my time looking through check-ins in a GitHub repository, trying to find patterns that reveal technical debt that's accumulating in parts of the code. That is probably something that's much better left to an AI tool or some other type of automation that can do this much quicker, much less tedium and getting bored and starting to be sloppy and missing things. Something else that's very important, and Professor Jules White will talk about this in a moment, is helping to formalize the discipline of prompt engineering. You can think about prompt engineering as essentially learning to program these large language models using natural language rather than using third or fourth generation programming languages. Now, I think what's going to be happening in the future is more and more people will be programming this way rather than the way that us software developers have done for decades. But I think it's also relevant to point out that just as how a focus on good practices and software patterns are important for software development, learning to know the right prompt patterns will be a crucial knowledge transfer method for having us successfully interact with large language models. Now, a lot of people have pushed back on this idea of prompt engineering because they say, well, it's just a matter of time before the large language models get so sophisticated, we don't have to do these pattern parlor tricks with them anymore. They're just going to understand what we're trying to say. But I think that's a very reductionist and limited view of what prompt engineering really is about. I think prompt engineering, if you take a look at it holistically, is focusing on all these other quality attributes that we've come to know and love with software. Things like maintenance, versioning, configuration management, testing, and so on. And these are things that as we start to rely more and more on using these AI tools, either by themselves or more likely in conjunction with software developers, we're going to have to think about this holistically in the life cycle. And these quality attributes are going to be very important. And I don't think there's been little or no attention paid to this yet in the software engineering community until very, very recently. So let's turn our attention now to the impact of engineering AI-enabled software systems. This is the other side of the coin. So what is an AI-enabled system? It's a software-reliant system that includes both AI and non-AI components. And of course, this quickly gets us into other AI techniques that go well beyond generative AI. There's other forms of functional AI and analytic AI and visual AI, computer vision, speech recognition, augmented reality, and so on. So one obvious place where this is being done quite frequently nowadays is in infotainment systems. These are all those social media systems that either we or people in our family and friends spend way too much time on because they're addictive. And this is also a topic that's covered in more detail in other parts of the SEI's National Agenda study. in particular the topic on engineering societal scale software systems. A great example of this that's rolled out and used every day by most of us probably is YouTube, which is both a multimedia content delivery platform, that's the classic mobile cloud computing or web-based application style of development we've done for a long time, but now is increasingly using AI for things like recommendations, captioning, moderation, analysis, figuring out how to do targeted advertisements, and so on and so forth. So I think that's just sort of an obvious slam dunk that's going to continue at scale. Much more interesting uses of AI-enabled systems is for mission-critical systems, the types of things that you folks work on at the Naval Research Lab. And these would be examples that have come out in the last month or two, such as Palantir's AI platform, or AIP, which applies generative AI models to support battle management decision-making processes. And I think you can imagine how much more important it is to get those things right. We don't want it just to start hallucinating and doing weapons target pairing or attacking things that aren't actually hostile and so on and so forth. So this is an area that I think will become increasingly relevant for the defense world. Now, some of the things to note about this is that these AI-enabled software systems have very different characteristics than the traditional systems that were built without the use of AI. One obvious example would be non-determinism is often baked into them. So for example, if you take a look at ChatGPT and other LLMs, you'll see that they're intentionally designed to be non-deterministic. You don't want them to just give you back the same answer over and over again, even if you ask the question over and over again. You want them to emulate the way a person would react. However, this is not always what you want. If you're trying to build a system where the right answer delivered too late becomes the wrong answer, such as close-in weapon support systems for some kind of destroyer or cruiser that needs to evade incoming air threats, you don't necessarily want it to just make up its mind on the fly how to respond. If for no other reason, you'll never get it through the weapons certification board because they require a much higher degree of confidence and certification to authorize the use of these systems. Another area where things get different quite quickly is with emergent behavior, which in traditional systems is something we do not want. And in these AI-enabled systems, you end up with complex patterns that can arise spontaneously because of simpler elements interacting with each other or other parts of the system. And this, of course, is wonderful fodder for all these dystopian science fiction movies like Terminator series, or even going back to 2001: A Space Odyssey, where these machines become sentient and have a life of their own. Moving away from sort of science fiction, more technical, there's the extreme dependence on data in AI-enabled systems. In fact, the capability of the applications in these systems are largely determined by the quality, quantity, and the depth of the data. And therefore, testing of data has now become as important as testing of code. And what's interesting to note, if you look around and you try to find literature on testing of data, you'll just find that it's not nearly as well studied as testing of code, at least in the software engineering literature. So that's obviously a gap. We have to start looking at that path not taken and explore it in more detail. And then final point here on some challenges we have to address is going to be designing for explainability and fairness. If you want to try to use something like the Palantir folks have put forth, you really need to be able to show traceability from the recommended courses of actions that are coming out from this decision support tool in concert or in coordination with the mission goals, the resources, the evidence, the rules of engagement, various policies that need to be enforced, and so on. I strongly encourage you to watch their demonstration video. It's quite fascinating. It's still classified as forward-looking work, but I think it'll give you a good sense of where things may go. So what is the challenge here? Well, the challenge is how to identify and augment all our time-honored software engineering techniques for specifications, architecture, design, analysis, deployment, and sustainment, and so on, and apply them to these AI-enabled software systems. Now, if I was a betting person, if I was trying to pass along some sage advice to the next generation, I would channel my inner Mr. McGuire from the classic movie The Graduate. If you recall, Mr. McGuire told Dustin Hoffman's character, I have one word to say, I want to say to you, plastics. So the two words I want to say to you are assured AI. I believe that is probably the hardest thing we're going to have to address as a research community, is how to assure these types of systems. Now, why is this important? Well, it's very important, particularly for the DoD, because more and more people are planning to fight the next set of wars, and probably already doing this, using AI-enabled software systems. The tricky part for us, for the US, is not everybody else out there is as equally concerned as we are to make our software-reliant systems safe and have them avoid mishaps and collateral damage. So other people just want to have them go boom We want to have them go boom or whatever they do at the right time in the right place to avoid any unintended casualties. Now, how are we going to do this? Well, one way, which is a focus point of the DoD for some time now, is to continue to focus on shifting testing to the left. In other words, getting it in earlier phases and throughout the entire software development lifecycle and system engineering lifecycle. But that's true for everything, not just true for AI. I think the other key theme we're going to have to do here is figure out ways to perform continuous quality assurance at runtime. It's not going to be enough just to test these systems in the lab or in the software integration laboratory or be able to do it in the operational testing and evaluation context. They actually have to be testing themselves at runtime to make sure they're not going off the rails. Now, there's a whole other set of discussions about this kind of challenge in the SEI's National Agenda Study in the area of assuring continuously evolving software systems. That needs to be updated with these newer ways of attacking the problem. There's some interesting work that's been done in the context of auto GPT, which is basically applying GPT recursively on itself to try to prevent the hallucinations and keep things within guardrails. Interesting stuff, probably quite relevant for infotainment systems, probably quite relevant for decision support systems. When you start looking at safety critical real-time systems, this gets really tricky. And it may take a while for anybody to feel comfortable trying to use this technology in the pointy end of the spear, if you will. But that's something that people are thinking about, and places like DARPA and the Software Engineering Institute and other areas that are doing research are thinking carefully about this. So at this point, I'm going to transition over to my colleague, Professor Jules White, who's going to talk about his experience applying these technologies in a whole bunch of different areas.
Thank you, Doug. I'm going to really zoom in here on this prompt engineering aspect that Doug mentioned. And I think this is going to be a really, really important area that we understand and look at going into the future, particularly for software, but also hinting at what Doug talked about, which is this issue of what happens when we actually start programming within the large language models themselves, as well as externally. So one of the things I think it's most important to understand when we start talking about large language models and thinking about their capabilities in terms of software is really thinking about iterative refinement. And I'm going to show you an example of this that's going to end with the production of some software. But the way that I think about this is a lot of the discussions that you see in the news are people asking one-off questions. They say, tell me the answer to this, or write some code that does this thing. But the real power of these tools is in having an ongoing conversation where you take some product and refine it over a period of time. And so I'm going to give you an example of that. But the way to think about it is, I think if you look in the news, people talk all the time about all the errors that are made. And it's like looking at it as if you handed Michelangelo a hammer and he hit the stone once and he looked at the stone and he said, it doesn't look like this beautiful sculpture. And so he would throw the hammer on the ground and say it's a bad tool. And no, what Michelangelo would do is he would take that hammer and he would hit and chip away at the stone until he gets something beautiful out of it. And that's really about how we have to think about the use of these tools, is not one-off, ask it a question and get an answer, but thinking about it more in terms of iterative refinement and a conversation, particularly when we talk about software and prompt engineering. So I'm going to start off with an example that's going to be outside of software, and then we're going to wind up with software. And so the example I'm picking is something that I think would be very difficult for a human to do, and certainly would be expensive to get a human to do it. And so what I'm going to say is, please create a meal plan for my family that is based on a fusion of food from Ethiopia and Uzbekistan. I want to eat keto and up to 2,000 calories per day. Pick dishes where the ingredients are easy to get from the average US grocery store. So this is a hard ask. And if you think about it from a software engineering perspective, really what I've got is a whole bunch of different requirements that have to be integrated into the answer for this. And so if I go and ask ChatGPT this, basically instantaneously, it says, okay, here's a sample meal plan that combines flavors from Ethiopia and Uzbekistan while also being keto friendly and within a 2,000 calorie per day limit. And it goes on to say you can have breakfast scrambled eggs with sauteed onions, tomatoes, and Ethiopian berbere spice. And then notice what it does is, in parentheses, it's after berbere spice, it says made with chili powder, paprika, garlic powder, ginger, cumin, and coriander, because it knows that one of the requirements was that it had to create things that were easy to get from the average US grocery store. So it has this deep understanding, and I'm using that word very loosely, of what the requirement was. We could go on and say, well, how do we take this? And this is kind of one of the refinement aspects that I think is really important, is when we think about software systems, they don't live in isolation. They're supporting human systems. And one of the things that's really important is to be able to take software and reason about it and work with it in a larger context, or mix different requirements together with real systems. So I'm going to take my meal plan and now I'm going to mix in sort of an unusual requirement. which I'm thinking about my son, and he's 9, and I'm thinking, well, if I'm going to implement this meal plan, I need a way to get him to try it. So I go back to ChatGPT and I say, my son is 9. Sometimes he won't try new dishes. To make this culinary adventure more fun for him, can you create a short Pokemon battle story to go with each dish? I will read the stories with him before dinner to get him excited about trying the new food. Make sure the story ends with a cliffhanger that will motivate him to try the new food. And ChatGPT very quickly will then say, Pikachu and his friends were exploring the wilds of Ethiopia, and they were suddenly ambushed by a group of sneaky Pokemon thieves. And then it goes on to say, towards the end, in the end, they emerged victorious, but not before the dragon left a fiery spice that imbued their breakfast eggs with a flavorful kick. Can you help Pikachu and his friends defeat the Berbere dragon and enjoy a spicy breakfast? So it's taken our original meal plan. It's now taken the Berbere spice that was in that first dish, which it showed us that we could get from an average U.S. grocery store. It's turned it into a larger context. It's taken a new requirement, which is we need to get a 9-year-old to try the dish. And then it's actually ending with a cliffhanger, which was part of the response. So it's doing really complex analysis of the requirements that we're giving it and generating outputs to meet those requirements. So I'm going to take this a step further because I want to show that we don't just have to think about it as generating outputs, but we can also think about building sort of interactive paradigms with it. So I thought about, well, what are the other things that we do at dinner? And one of the other things we do at dinner is talk about what my 9-year-old is learning at school. And one of the things he loves is math games. So I thought one way to make this new meal plan more exciting for him would be if I could come up with some way to integrate math games into this whole thing. So I said, ChatGPT, I would like you to play a math game with my 9-year-old to teach him about division with fractions and nutrition. Ask him questions one at a time involving Pokemon and these topics and make it into a game. When he wins the Pokemon win, ask the first question. And I'm starting to use a lot of prompt engineering in here to get this to happen. So ChatGPT says, okay. And it says, question 1, Pikachu and his friends are planning a meal that includes half a cup of cooked rice, but they need to divide it evenly among 3 Pokemon. How much rice will each Pokemon get? And then ChatGPT stops and it waits for your answer. So what we've done is basically we've taken ChatGPT, we've developed this whole meal plan, we've developed these Pokemon stories. Now we're turning it in, reshaping it into a math game. And we've actually turned it into a completely different paradigm where now it's asking us questions and waiting for our response. So now if I go and I enter 1-6, it will then grade the response, which in this case it's correct. It says, yes, that's correct. And it works out the math for him. And so we've actually now built a math game within ChatGPT. We've actually programmed within ChatGPT. And so we're building this whole complex product to support this meal plan through a set of requirements. But now I'm going to actually take it and I'm going to produce some software to go along with it. And this will lead us into the software piece for the rest of it. So I thought, well, this is great that I've created this game within ChatGPT. Can we take that game and turn it into software? And so I say, let's create code for this in Python. And I give it some requirements about the Python APIs I'd like to use. And then it says, sure. And it generates the code to implement this math game as a web app in Python. And then this is it running in the browser. And so one of the things that's really important when we start thinking about this new paradigm is the flexibility it gives us to take requirements, shape them in all kinds of different forms that interact with real human systems, but then also create software to support different aspects of the human system and to rapidly iterate and evolve on that. And so I'm going to talk about that rapid prototyping in a minute and come back to it. We can really quickly get to software if we know how to engineer all of the prompting. So a lot of what you saw and what I was doing is built on our research on this idea of prompt patterns. These large language models are essentially taught by getting them to predict the next word in a sentence over and over again on large volumes of text from the internet. And essentially what they're learning is patterns in our language. And so what we've looked at these large language models as is essentially a new computational paradigm, kind of like a new computational architecture that has all of these unknown capabilities in it. And we're taking patterns in our language and using the patterns and looking at what sort of computational or emergent capabilities they trigger within the architecture, and then documenting that, similar to how we've documented software patterns, and looking at and understanding what patterns you need into your language to tap into those different emergent reasoning capabilities or to get better outputs. And we have a bunch of papers that cover this. A bunch of the patterns that I'm going to be showing today are coming out of these 2 patterns, in particular the second one that's all about patterns for software quality. So I'm going to give you an example of one of these patterns. And one of the things we see a lot of concern about with these large language models is that people say, oh, well, they produce bad code or insecure code or that things. And what I say is they absolutely can produce bad code if you don't put the right patterns in your language when you're asking for the code. So if you don't have the right prompt engineering, you don't have the right patterns present in your ask for the code, you're going to get bad code out. And so what you need to know is how to ask for and get code generated that's of higher quality. And so I'm going to give you an example of this. We call it this principled code pattern. And basically the idea is this: when you ask for code, you tell the large language model what sort of coding architectural properties or standards or other things you would want it to follow. In this case, I'm going to give you an example with the SOLID coding principle. So SOLID is a set of coding principles that are common in object-oriented programs. They're single responsibility, open, close, list-off substitution, a bunch of other ones, but they basically revolve around the design of the software itself. And so I'm going to ask ChatGPT through some prompt engineering. I'm going to say, act as an expert software developer. From now on, whenever you generate code, make sure it follows SOLID principles. And so basically, rather than just ask it to generate code, I'm going to say, no, when you generate code, it should follow SOLID principles. Now, and this is also true if you evaluate code. So I'm going to take an example with evaluation of code, where I told it, any code you produce, you're going to have to follow SOLID principles, or if you evaluate code, I take a very large input of a very sloppy, procedurally written Python program, and I'm going to paste it into ChatGPT, which is what I'm doing right here. And I've just provided a subset of this. This is actually a much, much longer piece of code. And the output from ChatGPT then is it goes and applies SOLID principles to the code, and it says single responsibility. The context class has several responsibilities, such as tracking the current state, function lookup, and adding outputs. It would be better to split these responsibilities into separate classes. For example, the state management could be handled by a state manager, and it goes on to talk about this. Open close principle. The function lookup dictionary in the code is tightly coupled collection of functions. It would be better to create an interface for each function and have each implementation of the interface as a separate class. List-off substitution principle. It says the prompt class has several optional fields. This is data, steps, and invocations. So better to create subclasses. So it basically takes this very highly procedural, sort of tightly coupled code. It applies the SOLID principles. It then is telling us, here's how you could refactor the code so that it would actually follow them. And then the next thing it does is generate the refactored code, which if you compare the start and after, and you can't really do it in slides, it's hard to do it. It's a much bigger volume of code. The version that it produces that follows the SOLID principles really do take the original code and refactor it significantly to dramatically improve the code quality, but not just in the sense of less vulnerabilities or it's more efficient. No, it actually fundamentally looks at modularity and abstraction concepts and improves them. Things that would be difficult for my seniors in software engineering to do, something that you would have to probably have a more experienced senior software engineer to actually be able to pull off on a set of software. So the way I think about this is like, the reason prompt engineering is going to matter, certainly for the near term until we have these Uber LLMs, which may or may not happen, is because if you get the prompt right, it might generate code that's 20% faster. Maybe it's 50% more maintainable in the long run. Maybe it's more secure, but you really have to think about the wording and the patterns that go into your language. And we've done a bunch of research that's ongoing, particularly on the performance of code, that shows that how you ask the question, how you ask it and instruct it to generate the code directly will impact the performance that you get out. So if you just say, give me Python code to do this, it's going to give you some random solution that it saw at some point in its training, probably off the internet, or something that looks like that. If you say, give me something that's fast, as the size of the list grows, it's more likely that that pattern was seen in the context of highly performant code. And so you're probably more likely to get higher performance code out. And that's what our research is showing when we're doing this. And we're looking at lots of prompts, generating code with them, and looking at probabilities that we get faster code out. And I think this is sort of intuitive. You can think of it as the prompt is basically putting a target out that the large language model is trying to generate some output that hits that target. And the more precise you are in the specification of that target, the more likely you are to get what you want. So if you just so engage, give me code, you're probably going to get something that's not the best performing. If you specify more specifically, this, as the size of this list grows, I want this code to be fast. It has more of a specific target to hit. Now, one of the things that I haven't seen as much discussion on in the use of large language models is the real transformational capabilities they have in rapid prototyping in the software engineering world. And so I'm going to give you an example that uses three of the different patterns that we talk about. One is requirements generation, two is API generation, and the third is the API simulator. I'm going to start off with, and this was part of a talk I gave at a company called 40AU where I did this on the fly. And I said, we're going to create a Python API for a lunch and learn series. And I want you to create a Python API that can store information about the upcoming lunch and learns at the company. And I want you to generate the requirements. And it can go and start generating requirements. And it actually does a really effective job at fleshing out initial requirements and then helping to support users through brainstorming and thinking through what are all the different aspects of requirements. It doesn't replace the human, but it really helps in accelerating the production of the initial requirements and making sure that you're not missing things. Now, in this example, I'm not actually going to write any requirements myself. I'm going to have it generate all the requirements. And I'm going to actually do everything we're seeing here is done 100% with it deciding the requirements. So I said, generate the requirements. And it generated requirements, event creation, the date, time of all these lunch and learns, things like that. So then I go and I say, okay, based on the requirements that you generated, please generate an open API specification that will implement these requirements. So open API is a specification language for describing HTTP APIs or REST APIs. And it just takes its own requirements that it generated, and then it generates the open API specification document in YAML, which is what we're seeing here. And it's a very long specification. I've just excerpted it. But you can see we have an API endpoint for looking at the current set of events. We can get the list of events. It has all the parameters that we can provide to it. And it's basically taken its own set of requirements for this software system. It's generated an API based on its own set of requirements. And notice the API itself is not real. There's no code. It's just the specification for the API. So the next piece of this is I'm actually going to rapidly prototype. I'm going to say, I want you to simulate this API without actually generating code. So act as a REST API based on the specification. I'm going to type in HTTP request, and you're going to respond with the HTTP response, basically that API would get. So I'm telling it, don't even go and generate the code. Just within the LLM itself, I want you to simulate what this API would do. So I'm going to then go in. And in this example up here, I'm typing in an HTTP request, which is get/events. So I'm saying this is like simulating sending an HTTP get request for the /events. And then down here beneath it is ChatGPT responding with what that endpoint would respond with from its open API specification. So it says, okay, you got the /events, and here's the list of events. It's introduction to machine learning at the 40AU headquarters. Here's the date and time. And it's exactly matching up essentially with what it had said before. I can then go and flexibly interact with the API to brainstorm and imagine how this thing might work. And I can say like post to /events. And then I just put in some ... data that looks like an event. And I tell ChatGPT, you fill in this event for me and simulate what happens. And so it says, okay, and it simulates me posting a new event, and it generates all of the data, the sample request for my data, and sends the post to the server. I cut it off, but it also shows the response out of it. And what's also interesting is if you start interacting with the API, it'll actually remember the posts that you've sent. And so when then you go and you get the events again, you'll see them. But where it gets interesting also from a prototyping is you can think about, okay, well, if I'm a programmer and I'm working with this API, how would that API work? And how would I interact with the pseudo API before I've even built it? So I can say, give me some code samples in Python for interacting with this API. And notice I haven't implemented, I've just had it generate its own requirements, it generate the API specification, and now it's simulating it. And then I can have it generate code. If I had the API design that this is what it might look like to interact with it in Python, and it shows me sample code to interact with it. So they can really quickly help do rapid prototyping, help generate and improve the quality of code, doing things like application of solid principles or security principles. But they can also do a lot of things that I think will also help the software engineering space. Like imagine if we took a team that was developing software products, and we have multiple teams like the front end and the back end team that are making decisions about the software product, and they're doing those things independently. And what happens in the software world? Well, you have two teams that are working independently that make conflicting decisions, and late in the game, you go to integrate and you realize there's a problem. So imagine if you just take all your teams and you have ChatGPT start summarizing the meeting. So you record the meetings, you transcribe the voice to text, you have ChatGPT summarize the meetings, and then you have a workflow of prompts, an architecture that's running automatically in the background where every meeting summary gets put into a series of prompts where it says, please identify any conflicts in approach in the product between these teams. And then if anything comes out of that prompt, you then feed it into another prompt, which is please provide 3 possible resolutions for each issue. And then you take that and you can send it into another prompt, which is like score each of these resolutions based on organizational priorities, cost, and time, and then send it off to the leadership so that they can know about the conflict early in the game. Now, it may not be perfect. It may not catch everything. But compared to where we are today, where we're relying fully on humans And it's really hard to automate this aspect of looking at and detecting conflicts. You can imagine any tools that we can bring to bear on this, something like ChatGPT, looking at meeting summaries and trying to identify conflicts, could be really, really powerful. But there's all kinds of use cases like this where we might want to go through and be able to analyze human communication and use it to help improve coordination amongst teams or in design. Another example of ways we might use it to help teams out is you can imagine that you're taking weekly usage data from your product or your software system. And then at the end of the week, you run that data through a series of prompts. You tell ChatGPT or some other tool, summarize the most common user errors in the product. And if anything comes out, you then send it into another prompt, which is write short training tutorials on each user area to help prevent them in the future. And then if anything comes out of that, you send it over to another prompt, which is create a customer training email announcing the tutorials. And then when the product team comes in on Monday, based on last week's data, they have a new set of training tutorials written that specifically target the most common user errors that are being made in the product as of last week that they could then go and send out. And again, a lot of this is based on automating and having whole architectures of prompts that we're flowing information through. So although we talk about prompt engineering maybe in the small as a single prompt, it could also be much larger in terms of architecture and how we use this within an organization. Now, as one last example that I'm going to wrap up with, I'm going to talk about this persona pattern, which is used a lot on the internet, but I'm going to show it in the context of cybersecurity. And so basically the persona pattern is you tell the large language model to act like some entity, some person, some organization, some role. In this case, I'm going to tell it to act as a senior security engineer. And I'm going to say, you're going to help me investigate potential threats to my organization. And basically, I'm going to tell it an interesting thing. I'm going to tell it, you're the security engineer, but you can tell me to do the following things. You can tell me to run a Linux command, and then I'll cut and paste the output of that command from the terminal back into ChatGPT. You can write a Python program that produces output to the terminal that I can then cut and paste back in so that you can see the response. Or you can write a Python script that goes and lists at the NIST vulnerability database. But the idea here is that we're going to have ChatGPT do all of the follow-up and all of the security analysis. And then the human is just going to follow the instructions of ChatGPT, run commands locally on the computer, and tell ChatGPT what the output was. So I tell ChatGPT I have a new device at IP address 192.168.1.105. And so it responds by telling me, I want you to nmap this address, and it explains why it's doing this. So if you're not familiar with nmap, this is basically a command line tool that you can use to go and do essentially a port scan of a particular host. So I'm going and doing a port scan of this particular host. And then what I do is I take the output of that port scan from my command line. So I went and ran this in a terminal. I took the output of that port scan against that host, and I copied and pasted it back in as my follow-up to ChatGPT. And it responds by telling me, okay, thank you for giving me the output of the nmap scan. Based on that, here's what we know. This host is up, port 22 is open, port 53 is open, port 80 is open. MAC address corresponds with this technical or delivery technologies in Belgium. Can't tell for certain, but it's probably Linux. And then it goes on and it says, I want you to run these two commands to give me more information on it. Now, the interesting thing is, at this point, I didn't really tell it up front if I had access to this host or not. So it's assuming that it has access to the host. So one way to look at it is, oh, it made a mistake. But another way, going back to that iterative refinement, is I just say, look, I don't have access to this device to run the commands on it. And it adapts itself and it says, okay, I understand you don't have direct access. In that case, let's gather this information alternatively. And so it gives me the NC command. So it says run NC-V on this particular host on port 22. And it tells me this command is going to attempt to establish a connection to the SSH server and retrieve the server banner, which often includes the version information. So it's actually trying to figure out, okay, I know there's a SSH server on there. I'm going to try to read its server banner and figure out what version it is. So I go and run that command. This is the output from that command. I copy and paste it into ChatGPT. And then it says, thank you for providing the SSH server banner. It appears that the SSH server on the device is running dropbear SSH with version SSH 2.0 dropbear. And this whole interaction keeps going. It keeps going to the point where ChatGPT has me run some custom Python code that it generates in order to determine information about the HTTP server, and goes through, and then finally it gives a recommendation on the security of this device on the network. But this kind of shows you that there's real depth and complexity to the capabilities, and we're just sort of scratching the surface. And then the last thing I want to show is this aspect that Doug touched on, which is this idea that we can program within large language models themselves. And essentially, we're going to greatly expand the scope of who can program and how, and we can do sort of just-in-time programming of tools that we need to support us. So as a quick example of this, I'm going to quickly write a program to help me analyze my email. So I'm going to say, act as my personal assistant. Whenever I give you a long email thread, you will create a bulleted list of questions and action items. The bullets should be numbered. If I type in a bullet number, you will summarize the conversation from the email chain around that bullet in one paragraph. If I type in a bullet and a number, you will draft a reply for me to read with that many paragraphs. So I'm creating an email program. It's going to summarize any long email thread, like you might have gotten it over a weekend where you weren't paying attention to email, and just tell you what are your action items. And then it has a menu system. I can either type in the number of a bullet and it will expand on the conversation around that bullet and summarize it, or I can have it draft a reply. So I've built an entire application within ChatGPT. This is me cutting and pasting an entire email chain that Doug and I and some other faculty members were scheduling one of our courses that we're going to run in the fall. And we had this long email chain trying to figure out where could we have the course, what time and what room. I copy and paste this into this program in ChatGPT, and this is its output. It says, what are the suggested title and transcript? What should be included in the course description? And it basically pulls out every one of the action items that we were discussing. And it numbers each of them in the outline. And then I can go in and I can use my menu system that I built in my program and type in 1.7, which is one of the items. And then it tells me and summarizes around that particular topic in the thread. And it says, in the email thread, the team discusses the room and schedule for the course. Sharoz suggests is Tuesday, Thursday, 9:30 a.m.'s time slot, but the only available room at the time is Engineering Science Building 048 with a capacity of 60. Jules approves of this room choice, mentioning it as a good size for the first run of the class. The conversation does not provide any further details on the room schedule, so it seems that the team has agreed on. And I love this last part because it's basically inferred. Nobody said, I don't like that. Nobody did anything else. And so we've sort of agreed on it and it's moving on. Hopefully this will give you a sense of the scope and potential for these tools to be used in software engineering and security. So with that, I'm going to turn it back over to Doug.
So want to wrap up here so we have time for questions. Learning to use these types of tools that Jules was just talking about and I mentioned earlier is absolutely crucial if we're ever going to get to this point of achieving a vision where humans and AI work together as trustworthy collaborators. So even though I think we've accelerated the pace at which we will be doing this, it may still take 10 to 15 years to get to the point where we trust it as much as we would like. Clearly, as you just saw from Jules's examples, we're getting much better at being able to take the intent expressed through natural language or some type of structured natural language in order to be able to rapidly evolve software-reliant systems at all phases. I thought what was particularly relevant for what he was talking about was that we're giving it solutions that already are known to work and then asking it to help improve them. And that's a little different from just expecting ChatGPT to generate perfect code every time from just high-level specs. It's also, of course, going to give us humans more time to focus on the fun parts of software. And I find myself, when I use these tools, so much more productive, and I'm having way more fun than I used to have when I would write software because I don't have to worry about all the mundane stuff. Let's let the tooling handle the mundane stuff. We can focus on the things that are interesting and require our big brains to be creative. So last couple slides, there's a lot of work that has to be done to get this vision where we can work together in a trustworthy way with AI tools, but the barrier to entry is very low. So now is the time to jump in. And the other thing to note is that there is going to be very quickly a digital chasm much wider than the digital divide. The digital divide we've talked about for decades has been people lacking access to the internet and the web and computing. Now it's going to be people who know AI and how to use it versus those who don't. And there's a classic quote that says, AI will not take your job, but someone who knows how to use AI better than you do may take your job. And I think that's what is incumbent upon all of us to up our game, to learn the good and the bad and the ugly of these tools and be more effective at how we create and secure and deploy software. So with that, we will stop and take questions.